Imagine a world where the speed of light isn't constant. Sounds strange, right? Yet this concept is something that tickles the curiosity of scientists and students alike. The speed of light, represented by the symbol c, is a fundamental constant in physics. It's a steady number, clocking in at approximately 299,792,458 meters per second when traveling through a vacuum. This unwavering speed is not just a random number. It's a pillar of modern physics, a backbone that supports a multitude of theories and principles. Among them is Einstein's special theory of relativity, a theory that has revolutionized our understanding of time, space, and gravity. Einstein's theory of relativity is a two-part theory. The first part, the special theory of relativity, relies heavily on the constancy of the speed of light. It states that the laws of physics are the same for all non-accelerating observers, and that the speed of light in a vacuum is the same, no matter the speed at which an observer travels. This constancy is the linchpin that holds the theory together. From this constancy, Einstein derived profound concepts such as time dilation, length contraction, and the equivalence of mass and energy. Time dilation describes how a clock moving relative to an observer will tick slower than a clock at rest. Length contraction suggests that objects are physically shortened when they travel at speeds close to the speed of light. And the equivalence of mass and energy is famously encapsulated in the equation E equals mc squared, which tells us that mass and energy are interchangeable. All these concepts, which form the fabric of our reality, hinge on the constancy of the speed of light. If c were to vary, it would mean rethinking these foundational principles. It would mean reimagining reality as we know it. So the speed of light is a cornerstone of our understanding of the universe. But what if it wasn't constant? A universe with a variable speed of light would be drastically different from the one we know. We'd have to revisit our cosmic measurements and astronomy. The constancy of the speed of light is like a reliable yardstick we use to measure the vast expanses of the universe. If this yardstick were to change unpredictably, our estimates of the universe's size could be off. The age of stars, the timing of cosmic events, our understanding of the scale of the universe, all these could be skewed, but the implications don't stop at cosmic measurements. The vacuum of space, contrary to popular belief, is not an empty void. It's a bustling marketplace of virtual particles popping in and out of existence, creating a quantum soup. These particles interact with photons, the fundamental particles of light, and if these interactions were to change the speed of light, our understanding of space itself would be altered. The speed of light also has a profound influence on the fundamental structure of matter. The strength of molecular bonds and the density of nuclear matter are determined by the electromagnetic force. This force is defined by the fine structure constant, which, believe it or not, is influenced by the speed of light. If the speed of light were to fluctuate, it could mean that the very building blocks of matter, the atoms and molecules that make up everything we see around us, might have different strengths and properties. Imagine a universe where the properties of matter are not fixed, where a single atom could behave differently at different times. This would not just affect the physical world, but could have far-reaching implications for chemistry, biology, even life itself. In short, a variable speed of light could turn our understanding of the universe upside down. Our modern world is built on the constancy of the speed of light. This seemingly simple statement underpins the intricacies of the technology and communication systems that we rely on every day. From the GPS that guides us on unknown roads to the internet that connects us across continents, the precise measurement of the speed of light is a cornerstone of these systems. Consider GPS technology. It involves a complex dance of signals between satellites and receivers on the ground. The timing of these signals is crucial, and it's all based on the speed of light. If the speed of light were to fluctuate even slightly, it would throw off the timing calculations. Your GPS might tell you that you've arrived at your destination when you're still miles away. The internet, too, relies heavily on the speed of light. Information travels through optical fibers as pulses of light. If the speed of light varied, it could affect the rate at which data is transmitted, causing delays and disruptions in communication. In our hyper-connected world, even a slight delay can have significant impacts, from financial transactions to emergency services communication. And it's not just our everyday technology that would feel the effects. Scientific instruments that rely on the speed of light for precise measurements would also face challenges. For instance, the Large Hadron Collider, which smashes particles together at near light speeds, relies on the constancy of the speed of light to calculate the energy and momentum of these particles. A variable speed of light could introduce uncertainties in these calculations, affecting our understanding of the fundamental building blocks of the universe. In short, a variable speed of light would necessitate a complete overhaul of our technology and communication systems. It would mean rethinking and redesigning these systems to account for the fluctuating speed, posing significant challenges in synchronization and accuracy. A variable speed of light could throw a wrench into the smooth functioning of our technology-driven world. But as daunting as these challenges may seem, they also represent opportunities for innovation and discovery, reminding us of the dynamic and ever-evolving nature of science. A variable speed of light might seem like a headache, but it could also open up exciting new possibilities in theoretical physics. Imagine, if you will, a universe where light doesn't always adhere to the speed limit we've set for it. This would mean that our current models, the ones we've spent centuries perfecting, might need a bit of a makeover. In this new realm of physics, researchers would be faced with the intriguing task of developing fresh models. These models would need to describe the interactions of elementary particles and radiation in a universe where the speed of light is as variable as the weather. Quite a challenge, wouldn't you say? But the real kicker is this: a variable speed of light could potentially lead us to a unified theory of physics. Now, that's a term you might have heard before. A theory of everything is the holy grail of physics. It's a single, all-encompassing, coherent theoretical framework of physics that fully explains and links together all physical aspects of the universe. Currently, our best theories, general relativity and quantum mechanics, describe the cosmos on a large scale and the subatomic world beautifully. However, they don't play nicely together. The equations of general relativity seem to break down when applied to the quantum realm and vice versa. A variable speed of light might just be the wildcard needed to bridge this divide and unify these disparate realms of physics. The possibility of a variable speed of light isn't just about rethinking old theories. It's about forging new paths in our understanding of the universe. It's about venturing into uncharted territories of knowledge, where the only certain thing is uncertainty itself. So while daunting, the idea of a variable speed of light could push the boundaries of our understanding of the universe. It's a reminder that in science, as in life, sometimes you need to shake things up to make progress. The idea of a non-constant speed of light is purely hypothetical, but it serves as a thought-provoking exercise. We've journeyed through the implications of this concept, from shaking the foundations of Einstein's relativity to altering our understanding of cosmic measurements. It would throw our understanding of the vacuum of space into a whirlwind, and even the strength of molecular bonds and density of nuclear matter wouldn't be spared. A fluctuating speed of light would send ripples through our technology and communication systems, demanding an overhaul to accommodate this new reality. Yet, it could also open doors to new frontiers in theoretical physics, hinting at a unified theory that bridges the gap between quantum mechanics and general relativity.